Hello, everyone. Welcome to another live session of Learn Microsoft Fabric with Merdad. It is Merdad. Good morning, good afternoon, good evening to everyone. And yeah, we're literally in the third session of Learn Microsoft Fabric, which is a fantastic thing, and very excited to start this session. And before that, just say thank you to all of you for all positive feedbacks that we have received, during these 2 weeks from the beginning live that we had. And yeah, let me share my screen. Good morning, Ingo. Cool. Let me bring up my slides and let's kick it off. So my name is Merdad, Microsoft MCP and Principal Data Architect and your instructor in this journey. I'm also a learner of Microsoft Fabric, right? We are all learning together, and I'm just, leading this, study group, let's say. And it is a pleasure for me to be part of this learning group. And let's learn and grow together. Just feel free to join the LinkedIn group. There we can have more, chats, and we can share our experiences and our, challenges that we had during the learning. And if you have any experience with the exam or with the learning path that you're busy with, just share your progress there, or even in the chat you can just say if you're planning for any exam, or if you have taken before, and what was the challenges. We can chat more about that. So we have completed the first and second session on May 25th and 29th. Fantastic. Today we are in the third session. And just a quick, explanation of the sessions ahead. The 8th session that is planned here is specifically for Build Edition Challenge that is going to be completed within a month. It is not a complete, path for DP-600 for this 8. And after this 8 sessions, we will have the other sessions for mastering the DP-600 exam, and of course the modules that we have in Build Edition are going to be part of the whole program of the Microsoft Fabric layer. So in the session 3, we are working on Delta Lake tables in Microsoft Fabric. And the module that we are going to cover is called Work with Delta Lake Tables in Microsoft Fabric. So what we are going to learn today, we are going to understand I always mix them up, data lake and delta lake. So we are going to understand delta lake and delta tables in Fabric. We are going to learn how to create and manage those delta tables using the Spark. And we're going to use Spark to query and transform data in delta tables, and also using delta tables with Spark structured streaming. First of all, let's see what is a delta lake. Delta Lake is basically an open source storage layer that adds some relational database semantics to Spark-based data lake processing. And it is somehow on top of the files and storage of a layer on top of the storage of data that are basically in the Delta format. And what is the Delta table? Basically, the tables that's in Microsoft Fabric Lakehouse that we have are based on the Linux Foundation, actually a Delta Lake table, and which is commonly used in Apache Spark, and it is called Delta tables. And when you actually explore them in the Lakehouse, you see actually triangle delta sign on underneath of them. And basically delta tables are a schema abstraction on top of the files in the Lakehouse, right, in the storage, that are going to be when you have a table in Lakehouse, you have some files underneath of that, right? And that table basically is an abstraction schema on top of those files. And files are basically the Parquet data, data file, which is containing your actual data, and also you've got your Delta log that is containing the log of the transaction that happened to that table, and it is basically stored in JSON format. The benefits of Delta tables, there are various beneficial there, and the first of them is it is basically there you can the relational table there. It is a basically it is a relational table that supports querying and modification of data. Basically, you can do the CRUD operations. What are the CRUD operations? Creation, retrieving the data, updating the data, and also deleting the data. Delta tables support ACID transactions. The ACID transaction, actually ACID is A for atomicity, which means that each transaction is a single unit of work. By transaction, let's say, for example, you are updating a value in a table, or in a value of a field in a row. This one is called a transaction, or the transaction can be, just some sequence of the activities in two or more tables. So the atomicity is covered here. We have the consistency that it means that when your data is going to be changed, it is going to be consistent there. And in terms of the isolation, we have when basically you you are changing something on one table in one record, it is going to be secured and safe, or and in the concurrent requests that are coming through the table, and you're going to have a valid status of your data. And also we have the durability, that it means that when a data has been changed or added or even deleted, it is going to be persist in database after finishing that transaction, And the next benefit of Delta table is data versioning and time travel. since we are actually logging, you know, in the lakehouse, it is logging the transaction logs that has happened to a table, from creation to update, delete, whatever that is going to be happen to a delta table. It is basically is going to be logged in the folder of delta log, and there is a version, and there's a possibility that you can just back to a specific version of your data. It is basically supporting for batch and streaming data that you can just use the structured streaming API in Apache Spark. And you can also have the standard formats and interactive with your data. The data format that is going to be stored is basically Parquet, right? And Parquet can be utilized by different tools in Fabric, and with also other tools that are working with data. And at the end, we can just use the SQL for querying the data. Let's talk about the lakehouse architecture. We need that for next 2-3 slides that we have about delta tables. So in a lakehouse, on top of the architecture, we have the meta store. Meta store is basically containing all metadata that defines the data objects in your lakehouse. The data objects can be the tables, views, databases, schemas, whatever that is related to your data structure is going to be stored in your meta store. Underneath of that, we have the catalog, which is a grouping of databases. And then we have the database or schema that is basically a grouping of objects in a catalog. And then we have the individual objects in a database, tables, views, functions, and so on and so forth. But this architecture is basically used in Databricks or some other stuff like that. In Fabric, we are basically using it is basically using that architecture, but when it is showing to us, it is simplified somehow, and we have the meta store. We have the concept of meta store that is the same story, contains all metadata that is actually that defines the data objects in a lakehouse. But underneath of that, we have seen. I'm sure you have seen the lakehouses in Fabric. There are two sections: file section and table section. In the file section, it is clear. We have the raw files, we have the files as is. And in the delta section, in the delta table section, which is an abstraction of delta files, we discussed that in the previous slides, that when we have a table, underneath of that, we can have the Parquet files and also the delta log folder, which has the the log files. There is a possibility to have the external tables. So there is a difference between managed and external tables. What are the managed tables? The managed tables are when you load a table in your lakehouse, right? Like what we have done before in the past 2 sessions. We chose a CSV files and just upload the file to the lakehouse, and we've seen the data is there. And when we click on the view files, we've seen the files underneath of that, the Parquet file and also the delta log folder. But let's compare managed table and external table. The managed table, table definition is in meta store. The same thing is for the external table. In managed table, data files, and definition is managed by Spark runtime. But in external table, it is only managing the data definition, and the files basically are going to be stored external in the external location than the underlying the table, right? But in managed table, we have the files underneath of that, so we can find the files. We can store the files in a specific path in the file section of our lakehouse. So it means that we can just separate the definition from the actual data. What is the beneficial? What there is that we can just firstly separate them, and when we delete the table, when we drop the table, the data is not going to be deleted from those files, and only that abstraction above the table, above the data, is going to be deleted. But in the managed table, when we drop a table, all the files, the Parquet files and transaction files, are going to be deleted. It is this, the previous slide, but for managed table that I mentioned, the Parquet data files and log files are all stored underneath of the table itself. But for external tables, now the files can be moved or moved to the file section, but there is a mapping still between the delta table and that actual data files. So how we can create these managed delta tables in Spark from data frame? It is, one of the easiest way to create a table is when we are creating them from a data frame. And in order to do that, for example, in PySpark, in whatever language that you are using in Spark, you can just utilize the APIs. You can utilize the functions that are available there. In PySpark, you can just use the save as table. And when you save the table, you can see the files underneath of that. Let's do that together. And let me share my, let's jump into data engineering. Let's create our Lakehouse DP-600 Lakehouse session 3, right? Session 3. And let's upload the file that I've got here for products. And it is going to be uploaded in the file section. We've got the products here. And so let's open in our workspace. Let's create a notebook. And let's add the lakehouse that we have created recently. Let me copy the script here. I put it directly in files, the products. So basically, we are just loading the data into the data frame, and for in this cell, and in the next cell we are going to just write it to a table. It's just showing the table, showing the data, which is in our CSV files. We can explore that. We can transform it somehow when we want it. Then we can just write it in the format of the delta, and we're going to save it as managed table. So once it is saved, which is still in progress, it is completed, we can just move out to the table section in our lakehouse and make sure the table is there. And also we can see the files underneath of that. We can see the Parquet file and the Delta log folder. Cool. It was the managed table. Let's create an external table that for the external table from a data frame in Spark, we use the same method of save as table, but we add another actually argument, another parameter to the that function, and specify a path to that to store the data. And let's just add it here, add another cell, and instead of this I would say files, and let's say data. Yep. So and the data is going to be available there. Let's just check it out in the file section. The data is there, but we've got our external table, and underneath of that there is nothing. Let me just when we click on that, nothing is happening, but rather we can see the external products here, the external table, and which is containing the Parquet file and also the folder. So it is separating the abstraction of data and the data itself. When we delete that external product, the files are going to be remain there. And so the next thing will be just comparing them and having an overview of what's happening with those tables and how we can compare that. We use a SQL section, SQL code to describe that table. That is going to show us if it is a managed table or an external table. Also, we can have other, properties, other metadata related to that table, and for example, where the data is located, right? And what is the format of that, and and other stuffs like that. So let's just let's go to our notebook, and it is called managed products. When we describe that, we mean that just give me a metadata about that table. It is managed, and also we can use the same thing for our external table, which is saying the type is external. So, and when we drop the table, as we discussed, we expect that the data for external table is going to be remain in its location. So let's do that with dropping table. When we drop that, it is deleted. And when we just refresh it, in the tables, there is nothing. And let's refresh the files. As you can see, the delta actually files and the Parquet files and log files are still there. And then we can create some, table on top of that, right? We can create the table structure, a schema on top of that. So we can basically create the metadata, right, on top of the table. And in order to do it, the data is sitting in a file section, and we can now create an external table, which is actually referring to its data in the data that we already have in the file section. So the table is going to be called products. It is using delta, and the location is exactly what we have in the files. It is there. The table should be created. Let's refresh it. We have seen that. Again, let's back to the lake house and just make sure that it is a, nothing is going to be happening. It is an external table. We can just make sure about this one. Let's copy this section to here, and let's say products. And it is showing us the type is external, and that's it. And of course, we can explore the data here to just make sure it is looking at that one, that data there. Let me check. Let me see. Oh, it is file data external product. Sorry, I missed something here. Let's drop this table and create it again. Let's drop the table. And here we should say data. And then we are going to check the product values here. Awesome. So, we have created the metadata in Spark using the SQL. We can also use another type of the metadata creation, which is Delta Table Builder API. We can do that, but it is going to create a managed database, managed Delta table for us. Let me create that one as well, just for testing purposes that we are not lying. let's call it managed products, and let's execute it. This succeed. In the table, we can see that. And in the lake house, we can see the files underneath of it. Of course, in order to utilize this Delta table, we need to import this library, Delta tables, and we can add the column. And in the adding column, we specify the name of that column plus the basically the type of that column. Sorry. Okay, so let's move to the next section. Yeah, we've created the metadata, and in some cases we need to save the data in Delta format, as a raw file, right? Not in the Parquet, not something else, as Delta, and no table on top of that. We can just creating the file without creating a table even, right? And that Delta file can be then loaded to your data frame, and you can work on that, or it is going to be only saved there for on other analytical purposes. So you can either overwrite that Delta file, I mean, and or if you have, for example, a new a Delta actually data from somewhere else, then it is going to be added to end of that file. We can do it together quickly. Let's just let's do it together and see what's happening there. Let's firstly create something here, and let's say df equals to what we have there. Let's use this. Right. The df is already has the value in it. That's fine. And let's only write it to a delta. I deleted that section for the path. You can use the variables like this to just specify the path that you want to utilize in in the next commands, right? And that variable is available in all cells. It is not only related to that specific cell in your notebook. And the data is going to be saved in Delta, and there's no specific table on top of it. And we only have the the file, the Parquet file, and also the Delta log, right? And the next section, of course, we can add the mode of overwriting or appending to the to that file. So we have worked with the Delta tables by using the SQL, but let's just do it in 2-3 ways to how we can modify our data, or even just selecting the data. In order to do that, we have two options in Spark. If we want to use SQL, one way is that you're embedding your SQL comment, your SQL statement in other languages. For example, here we have the PySpark and Python. And you can also use the SQL statement directly in your notebook cell by using the magic of SQL. And let's just test it and see what's happening there. For this one, we are using the SQL directly, updating the products based on one category. We are just changing the price there. Awesome, it is done. And just 32 records, for example, just affected on that execution. And for just using the embedding actually the values, let me bring my other things. Let's just write it down quickly. Spark.sql, and let's say select star from products. Very simple one. Yep. Oh, it is only showing the metadata of that. We can, of course, do it more. Let's bring another thing. Let's see how this one is working. It should be loaded somewhere to the data frame, maybe. And then that data frame, that display. Display the data frame. Yeah. So we can load that to a data frame, then display that. Sweet. So let's move to the next section. So we have created, actually we worked with the Delta table using the SQL, both embedding the SQL statement or directly using the SQL. And of course, we can, utilize the Delta APIs for working with the Delta tables in Spark. But it is mostly actually simpler way for when you want to work with the files. And for the tables, of course, most of the developers and data analysts prefer SQL, I think. There is a functionality in Spark, a feature that, as we mentioned, that you can just have the log, actually transaction log of your table, right? And all the modification, even the creation of the data, is going to be logged in your log folder and in the JSON language. You can, view the history of those changes and always access to a specific version by specifying the version number or even using the timestamp that is actually linked to that specific version of your data. It is in the table, it is in the table basically level. and we can always back to that history. So in order to do that, we can just have a look at the history of the table of the product, what we have done so far. Let's check it. We have created that, right? We have created that, and we have updated a some sort of the records there, which was updating the price unit price. Remember that. So if you would like to just back to that specific to that specific of that version, we can use the uh, you know the, for example, the PySpark functions to just say bring me the data as from that version. Let's do it quickly, and let me bring it up. So of course it is working with the delta delta log files. And here the path that is using is going to utilize the external products that we have here, and looking at the delta log. And yeah, that's it. It is going to just bringing up the current data, and which is available there, and also this reading the actually data from the Parquet file, and from there we can just find out what version of data we need to be loaded to our data frame. Oh, what's happening there? External products. Let me check the error that we are getting. Let's is reading the data and delta table path. External products. Let's check it out. And even we can use the table, and let's just say products, and let's see how it is working. Let me do this. Copy path. Yeah, it is working with the path. We need to find out why it was not working. We can just check it later, and not taking the time of the live session for now. But the list price, I wish, for the mountain bike that we have changed, previously, it is the current value of that 30.59. Let's just, here we've got another price, which is 33.99, for example, for the same product ID 771, and it is different in the original data. If I can find my mouse. Cool. Yeah, we've covered the time travel and working with the history of the data and how we can just always back to the actually status of our data. We can also, utilize the version number and also the timestamp, and which is basically sitting here. Let's quickly, just cover that. We have the version number one. This is starting from 0. Which is the creation of the table, and also we have the timestamps here. Cool. Let's move to the next section, which is related to the streaming data in Spark and how we are going to utilize the delta tables there. So, many data analytics actually scenarios are requiring the data to be processed in near real time, and they don't want to, wait for for the ETL processes or waiting for something like that. They want it right away, and they want it to be streamed into the Spark and into the Lakehouse, and then process them. Basically, for streaming the data, we have 3 main steps, right? The step 1, of course, the data is going to be produced somewhere, which is we call it source, and that can be, actually the data is constantly, changing and adding, to that data, and it is, actually it keeps producing the data for us. Like, we can have the delta tables when the data is going to be added or even modified in the in a table, right? And we can have the IoTs, which is Internet of Things. We can read the data from devices. If a device is working well, just imagine that in a server room, we have devices there, and the temperature of that, or even something is happening in the production line in an inventory, then so it can be recorded, it can be streamed into Spark and being processed, or even the network ports can be some sort of the sources. And we can have other type of the sources, whatever that you can imagine. It is going to in the real time that needs to be actioned immediately. For example, the event hubs in Azure, or even file system location when a file is added or deleted, actually, which is basically for added. When a file is added, then it is going to be informed to the this streaming process. So it is our source. It is going to be processed. It is optional. Sometimes we can just transform the data. We can select specific fields from that, received data, or even, we can just do some aggregation or grouping of the data. Once it is done, we can move that, actually push that to be stored in a destination, or in Apache language, they call it sync. And we also call it sync. And the data is going to be stored there. That can be a delta table. So as you can see, the delta table can be involved in both sections. It can be a source, and also it can be a destination in the streaming process. When we use a delta table as a streaming in Spark, which is going to be the source of the data. So the streaming, just let me just add this point here, that when we are talking about the streaming engine is going to be started somewhere and keeps listening to that source of the data. For example, here it is a delta table that we need to just listen to that. If anything is going to be happen there, any data is going to be added. Just keep in mind there is a note here that when you are using a delta table as a source, it only supports the append for streaming. It doesn't work for modified data. So to avoid having errors, you need to specify either the ignore changes or ignore deletes to have actually to not having any error there. And the data can be even shown here like this, or it can be stored in another delta table. What we are going to test today together is simulating IoT streaming in Spark. So the data, just imagine it is a production line. We have devices there, they are working, and they keep sending the status of the that device, that machine, to our Spark and say, hey, device 1 is okay, device 2 is not okay, device 3 is okay, or other kind of streaming. And after that, we can just quickly just take action on from that specific basically streaming that happened to that specific device. So in order to simulate that, we don't have now the devices available. We have to simulate it. And in order to do that, we create a JSON file that is, containing the actually a text file that is containing the JSON format, JSON nodes for each device. So let's do it together. Let me copy it, and that's it. So in order to do it, we need some libraries that are loaded there. Two libraries are related to the SQL, which are the data types and functions that are utilized in the script, and also another library for basically for the utilities of Spark and Notebook for having that streaming. Actually, for saving the file into a path in our file section. So we are going to firstly creating a folder. It is making a directory in this input path, which is already exists here. I just call it. Let's have it a new one. Just call it a data01, and it is going to be our input path. And as you can see, this input path is utilized in different sections that it is going to make the directory, or even putting the file and saving the file. And it is the data that we are loading to that text file. And so far, when we execute this guy, it is going to store our data somewhere. Nothing happened yet. And we can just confirm the data is created here, and it is in the text. Let me just bring it up in my file section, and it is a text file which is containing that the values of JSON. As you can see, the device 111, and it is okay, and in some point it is giving error to us, or another device. Cool. The data is there. Then we are going to just start the streaming, right? So I mentioned that the streaming should be started somewhere, right? And in order to do that, we've got the IoT stream, the IoT stream is here, which was created. It is reading the stream and what kind of a schema we are, reading the data from, and what is the option. The option is saying max file per trigger. So how many files is going to be actually taken from that path to be basically processed. So the data is there, and it is going to create a table for us in tables, and again, that streaming is going to be started there, and it is going to be started like this. And what it is going to do when this streaming is going to be started, we specify a table to a delta table to just keep the data there, right? And we have the checkpoint location option, which is basically a checkpoint of the successful, right? If successful, streaming. If something goes wrong with that one, it uses the previous, checkpoint, and from there it is going to continue reading the data, continue streaming the data. I hope I covered all the sections there. The data from that file is already loaded to our a table actually is created, and the table section, a delta table, which is called IoT device data, and if it loads. However, we can just quickly, select that data, see what's happening there. The data is there because it is listening to that text file, right? And the next step for us, just to testing, we are going to add more data to see if if data streaming is working well, and it is just listening to that and adding the data there. In the next code, I'm just going to add the data to the file, right, and not putting that, and not loading that to the table. So the data is going to be added to the file. It is added, and without any change, we can just execute this section again to see if the data is added. Yeah, we can just confirm that it is added. We can add it more and test it. And the streaming is working, right? Oh, was it completed? Yeah, cool. And once we are done, we can just stop this streaming. Of course, it can be part of a scheduled job to, or to having a constant streaming. But now we are going to stop the streaming. Hopefully, I completed everything here. Yeah, we are done with this section today. It is the time for the knowledge check. Yeah, kick it off. It's yours now. Let's have the answers in the chats. So let's see what are the comments there. As is, like the browser, thank you. Can we review the external table created where? I explained that. I hope this question was asked before that explanation, but for making sure that I'm covering and I didn't miss that, the external table is there in the tables, like this. Products is an external table, and the data which is an abstraction of the values of the data, and the data is basically sitting underneath of the files. Hey, Marie. And you're missing the data flow. I guess it was related to the section that we were testing the for that path. Thank you. Oh, sorry. Let me share my screen for the questions. Here you go. Let's give some time. Answer. Since there is a delay between the streaming destinations, I wait more, right? I think for LinkedIn is a bit longer than YouTube. But yeah, Shanti, for section, well, for question 1, you've got B. Awesome. By the way, Aziz, I didn't forget about creating the job definition. We will create that quickly together, and for those who was not actually available in the previous session, we missed one example of creating the Spark job definition. We will create it together once this knowledge test is done. Okay, I haven't received more for Shanti. For 2 is B, and also for 3 is A. Awesome. But it is BCA, and basically the Delta Lake is a relational storage layer for Spark that supports tables based on Parquet files. And for number 2 question is that when you want to actually save the data in your in your actually you have loaded the data in your data frame, and you want to just save it in the delta table, the format of that file that is going to be stored will be delta table, but the created files underneath of that will be the Parquet file, right? And also for the third one, if you drop a managed data table, it is going to delete both metadata and data files. Awesome, and congratulations, you've completed another module of this learning path, which is work with Delta Lake tables in Fabric. And we have completed the third session. The next session will be the session number 4 on June 5th, which is talking about data factory pipelines, and also actually ingestion data with data flows, which is somehow a heavy section, because both modules are included there. Just I included them together because they are somehow related to the data loading and data ingestion, data integration, I mean. And yeah, stay tuned for the next session. And Thank you very much for joining. I'm going to just have a test for creating a job definition in Spark. Let me just firstly let's create something quickly here. Cool. In order to use the job definitions in a Spark, we need a Python file, and in here, let's add something quickly to update a value, right? I hope it works like this. Let me check if we're going to add it, and yeah, we can just save it as Python, right? Let's keep it. And so it is our Python file. And in our workspace, we create Spark job definition. Let's call it DP-600 Spark job definition 01, let's say. And so here we can upload a file. It is, this is actually 3 sections of referencing. It is the main destination file actually that we're gonna have for this guy. Let me just call it for job definition file 01, and let's use this guy, upload it, and the lake house that we are going to work on that will be the lake house 3, which is good. Let's save it. It is saved. We can either execute it from here, or even in is created, and we've got it in what did the job description? Yeah, Spark job definition. It is created here, and here we can just schedule that, and for example, in which time it is going to be, how frequent this job definition is going to be executed, and when it's going to be started, and when it's going to be ended. We can just switch on and off the scheduler. And also the other thing that we can do is run it as is. It is going to be on demand running. Remember, if you remember for the previous session that we had, we could just run the job definition as on demand and manually, or we can schedule that. And here we can see the execution history of that job definition. Cool. I hope it answers your question, Aziz. For the previous session, I owed you this one. And yeah, thank you, Shanti, for joining. Everybody, thank you very much for joining the session, and which was a really fantastic one. I learned a lot. Also, we are learning together, as I mentioned. And just if you missed a part of this, session, you can just always back to the YouTube channel and watch the recorded video. If you like that, you can give me a thumbs up or share it with your friends, and let's grow together. Let's learn together. and share your experiences, share your progress with us. You can just share it in the LinkedIn group that was already shared. The QR code was already shared in the first of the session. And thank you very much. And until the next time, until Wednesday at 8 a.m. Pacific Date Time, take care and have a good one. Cheers.